Hey guys, so this is going to be an assignment alternative to the progress checks, and I hope these are a little bit more beneficial. So I'm just going to go through these problems right here. So use the first derivative test to determine local extreme values of the function and identify any absolute. Nah, we're not going to do that part. It's too late. I already printed these, but whatever. Okay, so the first derivative test, meaning let's find the first derivative. Y prime is going to be equal to 8x to the third minus 8x. And I'm going to set that equal to 0. It's probably helpful if I factor this. If I take out an 8x, I'm going to get x squared minus 1 equal to 0, and then that's going to be factorable to be 8x and then x minus 1 and x plus 1. Okay, and then so I have critical points. 0, x equals 0, -1, 1. So those are the critical points. And then the first derivative test just means I'm going to take values around these critical points and plug them into the derivative to see if it's increasing or decreasing. So if I take -2 and if I plug that in there, that's going to become negative, and if I plug in -2 here, that's also going to become negative. If I plug in -2 here, that is still going to be negative, but all together, when you multiply all three out, it's going to be negative. Okay, and then so I guess you can say f prime of x is less than 0 here. And then if I take a value here, so like -1/2, that's going to be a negative, and then that's still going to be negative. But then if I plug in -1/2 here, that's going to be a positive. So all together, that's going to be positive. So positive, so f prime of x is going to be greater than 0. If I plug in 1/2, that's going to be positive, negative, positive. So altogether, it's going to be negative. So f prime of x is going to be less than 0. And if I plug in 2, that's positive, positive, and positive. So f prime of x is going to be greater than 0, positive. And so local extreme values. So local extreme values are going to be, we're going to have a minimum here at x equals -1, we'll have a maximum here and a minimum here. Now to actually find the values, the actual values, you'd have to plug these values into the function itself. So if I plugged in -1 here, that's going to be 2. And then if I plug in -1 here, that's going to be -4 plus 1. So -2 plus 1 is going to be -1. So this is going to be, so the minimum here is going to be -1 at -1. If I plug in 0, I get 1. So the maximum is going to be 0 at 0. And then if I plug in 1, that's just going to be the same thing as the first one, right? Because if I plug in 1 here, that becomes 2. If I plug in 1 here, wait a minute. What did I do for this one over here? Hold on. So if I plug in -1, that's going to be 2. And then if I plug in -1 there, that's still -4 plus 1. That's -2 plus 1. Yeah. 4, 2 minus 4 is -2. -2 plus 1 is -1. Yeah, I did that right. So the minimum here is going to be -1. The minimum here is still going to be -1. Yep. Alright, now for this one right here, might be a little bit different, but same process. So we'll say y prime is equal to, this is going to require the product rule, so we'll do the first times the derivative of the second plus the derivative of the first, which is going to be negative e to the negative x. So I'll do minus e to the negative x, and then times the second And then if you simplify this, you can take out an e to the negative x. And then don't forget that this would have to be distributed then, but then we can combine like terms. So we'll have 2x. That's going to make it negative 2x, which will cancel. We're going to have negative x squared plus 2. And I'm going to set that equal to 0. Now, e to the negative x will never equal 0, so I don't have to worry about that. But then this part right here, so negative x squared plus 2, set that equal to 0. 2 is equal to x squared, so x is equal to plus or minus root 2. So we found the critical points. So we have negative root 2, we have positive root 2. Okay, and then we just got to plug in points around. So if I plug in 0 into the derivative here, e to the 0 power is going to be positive 1, and then that's just going to be 0, so 2, so I think we're going to have positive numbers here. And then if I plug in like negative 2, so negative 2, that's always positive. Remember that e to the negative x is always positive. Yeah, it's always positive. So then if I plug in negative 2 here, that's going to be 4, but then that becomes negative 4 plus 2, so this is going to become negative. And then if I plug in 2, the same thing is going to happen, so negative. And so we have a minimum here, and we're going to have a maximum there. Oh man, I don't want to plug these in. Anyways, you plug those in to find the actual min or max values. But there you go. Okay, use the candidates test to find the absolute extrema of the function and where they occur. Okay, so I need to find the critical points for the candidates test. So f prime of x is going to be equal to, remember that 1 over x is equal to x to the negative 1. So that's going to become negative x to the negative 2. And the derivative of the natural log of x is 1 over x. So this is negative 1 over x squared plus 1 over x. And I am going to simplify this by getting a common denominator. So negative 1 over x squared plus x over x squared. So this becomes x minus 1 over x squared. And I'm going to set that equal to 0 to find critical points, and then critical points are going to occur when the numerator or the denominator is 0, so that's going to be at x equals 1 and at x equals 0. So x equals 1 and x equals 0. So we have our critical points, so now we just have to, let's see, we just have to plug these into the function itself. So we have x, and we're going to plug it into function. Now, the thing is, 0 is not in the domain of the function. It's not in this interval that we have, so we don't actually need it. Also, we couldn't plug it in anyways because the function is not going to be defined at x equals 0. Yeah, it's not going to be defined at x equals 0. So, yeah, it wouldn't even be in the domain of the actual function itself. So, all right, so then we have 1/2 as the endpoint. We have 1 and we have 4. So if we plug in 1/2 here, that's going to become 2. So 2 plus the natural log of 1/2, and if you remember your natural log rules, that's 2 minus the natural log of 2. If I plug in 1, that's going to become 1 plus 0. That's going to become 1. If I plug in 4, that's going to be 1/4 plus the natural log of 4. Now, which one is actually going to be the highest of these? That's a good question. Just plug them into your calculator. Cool. I think this one might be the minimum. And I think this is going to be the maximum right here. Oof. I don't want. Okay, fine. 1 second. Where's my calculator? All right. So 2 minus the natural log of 2. So this is equal to 1.307, and 0.25 plus the natural log of 4. that's going to be equal to 1.636. So we got a maximum here, and we got a minimum here, the absolute minimum there. Okay. Here, g prime of x is going to be equal to negative e to the negative x. Cool. Which is equal to negative 1 over e to the positive x. Not sure if that really matters, but the thing is, this never equals 0. I can't set this equal to 0 because negative e to the negative x never equals 0. So that's cool. So then we just, that means that we don't have any critical points. That means we only have the endpoints. So we only have negative, so if we have x and we have e to the negative x, and then we just have negative 1 and 1, let's just think about this. Well, okay, and then if I plug in negative 1, it's just going to become e right there, and if I plug in 1, it becomes e to the negative 1, which is 1 over e. So obviously this is the maximum, and this is the minimum. And then if you guys think about the actual graph of e to the negative x, that's just e to the x just reflected over the y-axis. And then we're graphed from negative 1 to 1. So you can obviously tell that at negative 1, we're going to be at the highest. And at positive 1, we'll be at the lowest minimum. Yeah, there you go. Okay, and then here, so k prime of x is going to be equal to e to the negative x squared times by negative 2x. And we don't really have endpoints here, do we? So we're just going to have critical points here. So set this equal to 0, and then e to the negative x squared never equals 0. So the only time that this thing will equal 0 is if x is equal to 0. So that's the only point here. So that has to, so then if I do k of 0, that's going to be equal to just e to the 0, which is going to be equal to 1, which is going to be our min or max. And I'm just going to graph it really quickly to kind of confirm. So we have e raised to the negative x squared. That's what it looks like. And at x equals 0, there you go, it's 1. So it's a maximum. Okay. And we can't really say that there's a minimum. It's not on a closed interval, so it's not guaranteed that there's a minimum if it's not closed. Alright, so here, f prime of x is going to be equal to, so f prime of x is going to be equal to 2 over 5 x to the negative 3/5, which is equal to 2 over 5 x to the 3/5 power. Okay, and then if I set this equal to 0, well, it's never going to be equal to 0 because it's only going to be equal to 0 if the numerator is equal to 0, and 2 never equals 0, but this will be undefined at x equals 0. So x equals 0 is a critical point. And this can be plugged in right here, so f is still defined at x equals 0, so that's just basically saying that this is not differentiable at x equals 0, but it's still defined, likely resulting in a cusp or a corner of something like that. So then candidates test, negative 3, 0, 1 for f of x. If I plug in negative 3, that just becomes negative 3 to the 2/5, which becomes, remember that this just means two operations. It's being squared and rooted. So negative 3 squared is 9. So this becomes 9 to the 1/5. And then if I plug in 0, that's just going to be 0. If I plug in 1, that's going to be 1. What is 9 to the 9 raised to the 1 divided by 5 is going to be equal to 1.552. So this will be the maximum, and this will be the minimum. Alright, concavity test. Determine the intervals on which the graph of the function is concave up, concave down. Find points of inflection, right, as a coordinate point. So concavity test, so y prime is going to be equal to 12x squared plus 42x plus 36, y double prime is going to be equal to 24x minus plus 42. Set that equal to 0. So 24x is going to be equal to negative 42. And then that means x is going to be equal to negative 42 over 24, which is going to be equal to negative 21 over 12. Those are both divisible by 3. That's going to be equal to negative 7 over 4. So that is where the potential point of inflection is at. Only one, so it's at negative 7 over 4. Okay. So we just got to make sure that the second derivative does change sign. So let's plug in something like 0. So if I plug in 0 in here, it's positive. So f double prime is going to be greater than 0, concave up. And if I plug in something like negative 2, plug in negative 2 here, that becomes negative 48. Plus 42 is still negative. So A concave up, so that's going to be from concave up is going to be from negative 7/4 to infinity. Concave down, that's going to be from negative infinity to 7/4. And then a point of inflection is occurring here. You just have to plug it in here. I'll be honest, I don't want to do the math with a fraction. So negative 7 divided by 4. I'm plugging this into my calculator. So 4x to the third plus 21x squared plus 36x minus 20. And so the point of inflection is at negative 7/4 and negative 40.125. Okay. All right, so y prime here is going to be equal to 2 over 5 x to the negative 4/5. And then the derivative of 3 is going to be 0. So y double prime is going to be equal to negative 4 over 5 times by 2 over 5. And that's going to be x to the negative 9 over 5. So altogether, the second derivative is going to be equal to negative 8 over 25. X, I'm going to put that in the denominator, x to the 9/5. Set that equal to 0. So the only point of inflection could occur at x equals 0. But the function is still defined at x equals 0. And so it's likely going to be some sort of a cusp or corner or something like that, I would imagine. And so let's see. So at x equals 0, if I plug in a positive number, well, this is always negative. So negative over a positive number is going to be negative. So f double prime is negative. If I plug in a negative number like negative 1, this is to the 9th power, which would still make it negative, and a 5th root, which would still make it negative. So negative over negative would then become positive. And so concave up is going to be from negative infinity to 0. Concave down is going to be from 0 to infinity. And then if I plug in 0 into the function, I'm just going to get 3, which means the point of inflection is at 0, 3. I'm kind of curious just to see what this looks like. So I have, it was 2x raised to the 1 divided by 5. Yep, okay, that's weird. And then, yeah, you can definitely see it though. So it's concave up, then concave down. And then just plus 3, which would move the point of inflection to be at 3. Okay. Oh man, what the heck? E to the x, come on. We know that that's always going to be positive. It's always concave up. So, plus, I already know that its second derivative is e to the x, and that's always positive. And so it's concave up. So concave up is going to be from negative infinity to infinity. Concave down, never. And no points of inflection because it never changes from concave up or concave down. All right, here, so we have y prime, that's going to be equal to the first times the derivative of the second plus the derivative of the first times the second. I'm going to factor out e to the x there. That's going to become x plus 1. Then the second derivative is going to be the first times the derivative of the second, which would just be 1, plus the derivative of the first times by the second. And then I'm going to factor out an e to the x again. That's going to turn into x plus 2. Because once you factor out an e to the x, this becomes 1, and then this becomes x plus 1, so 1 plus 1, that's going to become 2. Okay, and then set that equal to 0. E to the x never equals 0. This will be equal to 0 when x is equal to negative 2. So negative 2. And if I plug in 0, let's say I plug in 0, this is always positive. That's going to be positive. If I plug in 2, so positive. If I plug in negative 3, that's always positive. That will then become negative, so this becomes negative. Okay, so concave down is going to be from negative infinity to negative 2. Concave up is going to be from negative 2 to infinity. And then if I plug in negative 2, the inflection points, so negative 2, comma. If I plug in negative 2, that's going to become negative 2, and then this becomes e to the negative 2. So it's just going to be negative 2 over e squared should be the point of inflection. Okay, and then now we're using the second derivative test. So let's say, so we need to use the first derivative though to find the critical points. So y prime is going to be equal to 3 minus 3x squared. Set that equal to 0, so 3 is equal to 3x squared. X squared is going to be equal to 1, so x is going to be equal to plus or minus 1. Those are the critical points. Okay, and then find the second derivative, that's going to become negative 6x. And then for the second derivative test, or I guess I should say y double prime. So we've got negative 1 and 1 as the critical points. If I plug in negative 1, I'm going to get, if I plug in negative 1, it's going to become positive. If I plug in 1, it's going to be negative. And so this means that the curve is concave up, which means that this right here at x equals negative 1 is going to be a minimum. So we got a minimum here. This is going to result in a maximum because it's concave down. And then if you plug in negative 1, you'll get the minimum. If you plug in 1, you'll get the maximum. So negative 1 comma 1 comma. So say I plug in negative 1, that's going to become negative 3. And then if I plug in negative 1 here, that's just going to become plus 1 plus 5. So 6 minus 3 is going to be 3. Okay, and then if I plug in 1, I'm going to get 3 minus 1 plus 5. 3 minus 1 is 2, plus 5 is going to be 7. Okay, so there are those. Okay, so y prime is going to be equal to 3x squared plus 6x. Set that equal to 0. I can factor out a 3x, and I'm going to be left with x plus 2. So at x equals 0 and at x equals negative 2 are the critical points. Second derivative is going to be 6x plus 6. Right, yep, okay. So then, let's see, I got x, got y double prime. Say I plug in 0, and say I plug in negative 2. 3x squared plus 6x. Set that equal to 0. Factor out a 3x. That's going to become x. X equals 0. X equals negative 2. Take the second derivative. 6x plus 6. Okay, yeah, no, I'm good. If I plug 0 into the second derivative, I'm going to get a positive number. If I plug in negative 2, you're going to get negative 12 plus 6, which is going to result in a negative number. So this is going to be a minimum here, and this is going to be a maximum here. So this is going to occur at 0. This is going to occur at negative 2. If I plug in 0, I'm going to get negative 2. If I plug in negative 2, that's going to be negative 8. And then if I plug in negative 2 there, that's going to be plus 12 minus 2. So this is going to be at 2. Okay, and if you guys want to check and graph these, that's probably a good idea. I'm too lazy right now. All right, for this one, so y prime, you're going to, oh man, we already did work for this right here. I'll do it again. So y prime is going to be the first times the derivative of the second plus the derivative of the first times the second. I'm going to factor out an e to the x. Okay, yeah, I remember. So y double prime, if I remember correctly, is e to the x and then x plus 2, right? Yeah. Anyways, take the first derivative, find the critical point. So the critical point is going to be at negative 1. Okay. So x, y double prime, so at negative 1. And then if I plug negative 1 into y double prime, this is always positive. If I plug in negative 1, that's going to be positive. So it's going to be a positive number, which is going to be concave up, which means that this is going to be a minimum. So negative 1 is going to result in negative 1 over e, if I plug that in, I believe. Okay. All right. Let's check this one out right here. Do the following. A, find the absolute extrema of f and where they occur. Okay. And so so that's the candidates test. So for A, let's first find critical points. So critical points, if we look at the table, critical points are going to be where the first derivative is 0 or does not exist. So first derivative is 0 here, does not exist. So the critical points are going to be x equals 1, 2, and then the endpoints are going to be obviously 0 and 3. So use the candidates test. So x, and then we'll have f of x. So we have 0, 1, 2, and 3. X equals 0, the function is 0. At x equals 1, it's 2, 0, negative 2. So so this is the maximum here, and this is the minimum here. There you go. Okay, and then for B, find any points of inflection. So points of inflection are when the second derivative is equal to 0 and changes signs. So when does the second derivative equal 0 or undefined? So it looks like we have all these right here. So we'll say x equals 0, x equals 2, and x equals 3. And then we just have to verify that they change signs. So 0, 2, and 3. So what about well, the function doesn't exist over here. So, or over here. Interesting. So between 0 and 2, the second derivative between 0 and 2 is negative. And the second derivative between 2 and 3 is also negative. So the function is always concave down. There are no points of inflection. No points of inflection. Do the following. So let me make sure that sounds right to me. Absolute extrema, we found those. Find any points of inflection, if there are any. But the thing is, so on the interval from 0 to 3, we don't know what the function is doing, if there is a function outside of this interval right here. And we can see that f double prime is just always, it's always negative, never changes, concavity, so there's no points of inflection. So yeah, no, that checks out. Okay, that should be everything for this. Hopefully you guys find it helpful. I hope you guys are just getting, this is mainly just to help you get the procedures down, and hopefully that's a little bit more beneficial than the progress checks. So, but yeah.